Okay, for our first example, the question says, what is the final balance of a retirement account earning 4% interest compounded weekly if $50 is deposited at the end of every week for 40 years? Round to the nearest cent. Okay, so first of all, what I notice immediately is that we have that periodic payment that's happening. In this case, it's the periodic deposit of $50. So we are certainly in the annuity world right now. So this is our big R, $50. We are looking for the final balance. So we are, in this case, looking for the future value of this annuity. So we are looking for what we call the S in this case. We have the interest rate of 0.04. This says at the end of every week, so the periodic payments are the same as your compounding, so this is the same weekly. So that would be 52 times a year for a time of 40 years. Okay, so we want to grab that formula and sub everything in. And again, I will be looking for this on your paper where you just get the formula and you put everything where it goes. That is worth credit and partial credit for me. So the R value is 50, and then we have a big set of brackets. We're going to have a big fraction in here. Inside here we have the quantity 1 plus 0.04 over 52, close that up, to the MT power, so the power of 52 times 40, minus 1. This is right here. If you're anything like me, that is what you have to be really careful that you don't accidentally forget. That gets dropped off a lot. So there's this extra subtract 1 on the top, and then on the bottom we have this same fraction, this 0.04 over 52. Okay, so now we have to calculate that. You can do all of this in your calculator at that point if you so choose. You might choose to do it in steps, like maybe you find the whole numerator and then you divide and hit enter and then you times by the 50. That's what I kind of like to do to avoid having to do parentheses inside of parentheses inside of parentheses on these. So the first thing I'd probably do is figure out what's 52 times 40, because that can help me a little bit. So that's 2080. And maybe I go from there. So what I'm going to do is I'm going to type in parentheses. I'm going to go on the inside. 1 plus 0.04 over 52. Close that up to the 2080 power. And you can tab back down if you want to, or just hit enter at that point. Then I have to remember to subtract 1 from that. So I'm going to subtract 1. It can be nice right there at that point to, it's going to be a rounded off answer, but sometimes it's a good place to write something down to look back on later if you need to redo the problem, like what was that? And then we're going to divide by, make sure you put this in parentheses, divide by what? Divide by 0.04 over 52. So that it divides by all of that. So I did all that part in my calculator. And at this level I get 5,134 and a bunch of decimal places. 0.982974. And then I have to multiply that by 50 to finish it. So let's see, my final answer is $256,749.15. Okay, so that is, and if you think, I mean, that's a huge number, but this is a 40-year retirement account. So that does seem logical there. Now, remember, those first big formulas just give us either the final balance or the present balance. And then if the question that you get asks you anything else, you'll have to do that first and then do some extra steps. So these are some examples of other questions that they could ask you and how you would get to those answers. So if they ask you how much was actually deposited into this account, okay, well, I don't actually need any big formula to answer this. I don't even have to do this part A first to answer this. What did the person deposit? The person deposited $50 every week, so 52 times a year for 40 years. So their deposit amount is just this multiplication, $50, 52 times a year for 40 years. So just multiply all that out. So this person deposited $104,000. How much interest was earned? So they could ask you how much interest was earned over this 40 years. Well, if this was their total and this was what they actually deposited, then everything else is interest. So if you're finding interest, remember, find that total value minus the deposits. And everything else is interest. So the total value is $256,749.15. Subtract off the $104,000 that they actually deposited there. And that should give you $152,749.15. And one other question that I've seen in the Newton homework is, what percentage of the final balance was interest? Okay, so if you're finding percentage, you're going to have to do some kind of a division. And it's of the final balance. So it's out of the final balance. So I know it's out of the $256,749.15. And what percentage of this was interest? So we just figured out the interest. So how much is $152,749.15 out of that total? So a division here, and I have not done that one yet, so I'm going to do that one now. So what is 152,749.15 divided by 256,749.15? So that equals 0.5949 and some change, or about 59.5%, maybe we would say. So their interest is basically 60% of their overall balance after the end of all of this. So well over half of the money is just money that they earned on interest, not even the money that they deposited. So that's the power of interest when it's working in your favor. A teenager's grandparents have decided to give her $5,000 per year for the next 4 years to help her pay for her college education. How much must they deposit into an account paying 8% compounded annually in order to begin making these $5,000 payments next year? So they can't front the entire amount that they need, but they're hoping that if they put some money periodically into this account, then they will make up some interest and be able to start paying out of this account from there. So what's interesting here is they're doing periodic deposits, right? So we're in the annuity world. This would be our big R. But the question this time is how much must they deposit? So this time we're looking for the present value. And we know that the time is 4 years, the rate is 0.08, and the M is 1 because it's just annually. So you hopefully have your formulas with you. I'm not going to scroll back up to avoid kind of going up and down a whole bunch. But this one we would set up as P equals the rate, the big R, so the periodic payment. Set up our big fraction. Now this one starts off as 1 minus, so it's kind of reversed of the future value. 1 minus the quantity, 1 plus the rate, 0.08, over the compounding period, which is 1 to the negative 1 times 4 power, and that's all on the numerator. And then in the denominator, we again divide by that fraction, 0.08 over 1. Now this could be simplified a lot before I go to my calculator. So it looks like I'm taking 5,000 times, on the top of the fraction, 1 minus 1.08 to the negative 4 divided by 0.08. Okay, so now I'm going to go into my calculator. And maybe I'm going to do this one in stages too. I'm going to do what's 1 minus 1.08 to the negative 4, because that gives me the numerator. Then I'm going to divide that by 0.08. And then I'm going to multiply that by 5,000. Okay, so let's see. The answer of $16,560.63. So that's what they want to put into the account. How much interest do they earn over these 4 years? Okay, well, to find interest, we always have to do like the total deposits minus, when you're finding interest, you do your total value minus the deposits. Or in this case, we're actually going to do like how much the total was minus what they deposited. Okay, so let's see. The important part here that's not specifically said is that they're wanting the total of this account to pay for $5,000 per year for 4 years, right? That's what they want to have total for their granddaughter. So they want 5,000 times 4. They want $20,000 in this account. And they are going to be able to achieve that by only putting in this much, this 16,560.63. So how much is interest? Well, they're going to eventually have $20,000 to spend, but they only fronted $16,560.63. So the difference in there is the interest that they earned. So it looks like they earned $3,439.37 in interest. So not a ton, but that's, a good chunk of one payment that they do not actually have to make. That was purely interest. So they're paying this $16,000-ish in order to eventually have $20,000 to give.